Alright, next up on the list is accelerated slipstream. Accelerated slipstream is related to p-factor. We'll start out by, again, as always, drawing two airplanes. A red airplane and a green airplane. We'll give them an engine failure, the standard. Left engine fail and right engine fail. As always, we'll draw asymmetric thrust, the turning tendency, in this case trying to roll this airplane to the left, and asymmetric thrust trying to roll this airplane to the right. As always, we'll draw the rudder trying to stop this airplane from rolling, and we'll draw the rudder trying to stop this airplane from rolling. Now, since we're talking about rolling motion, we'll make these aircraft a little bit three-dimensional. So we'll see if we can draw a three-dimensional wing there, and we'll draw a three-dimensional green wing right here. There we go. Not great, but good enough. It'll do. Once again, as you remember from the p-factor diagram, you've got a propeller, and the propeller. And the propeller generates more lift on one side of the blade. We'll draw that here. If you're creating more lift, I'm sorry, I didn't mean to say lift, I meant to say thrust. You're generating more thrust here due to p-factor. You're generating more thrust here due to p-factor. A result of generating more thrust is that you're going to also generate more backwards airflow. So when you generate more thrust here, you generate lots and lots of backwards airflow going over the wing, right there. And similarly, you generate just a little bit of backwards airflow going over the wing there. Same way, lots of thrust means lots of backwards airflow. And here, a little bit of thrust means a little bit of backwards airflow. Now, we don't need the thrust arrows anymore. We can get rid of them, because this is what we're going to be focusing on. As you can see, more airflow going over a wing, well, means more lift. That's pretty basic. Similarly over here, more airflow over a wing means more lift. What you're going to have in the left engine failure, the critical engine failure, is you're going to have the zone of maximum lift occurring somewhere about here. Whereas on the non-critical engine failure, you're going to have the zone of maximum lift occurring somewhere around here. Closer inboard, closer outboard. In this case, if the zone of maximum lift occurs further outboard, you're going to have a greater arm trying to bank the airplane to the left. This is accelerated slipstream. Over here, the zone of maximum lift closer inboard, you're going to have less of a tendency to bank the airplane, accelerated slipstream here. As always, the left engine is the critical one, because you need more rudder, you need more rudder to counteract this accelerated slipstream here than you do on this side if your non-critical engine has failed, and you'll need to compensate for a small amount of accelerated slipstream. As always, with anything related to p-factor, accelerated slipstream only exists in a climb or a descent. In this case, the diagram is referring to a climb.